Good afternoon, fifth period. This is Miss Bishop. I apologize that I'm not in class today. I am at a learning session, so I will see you tomorrow. But we are still going to do our notes for today. And the beautiful thing is that with this video, you can record or you can rewind and fast forward to meet your needs. So if I'm going too slow, you can speed it up a little bit, or if I'm going too fast, you can slow it down and rewind if needed. So let's go ahead and get started. So please make sure that you have your I can statement written down. It is, I can use inverse operations to solve one-step equations. Now, the first thing that we need to learn and that we need to know is that inverse actually means opposite. I can write this down. Opposite. So inverse just means opposite. So like the opposite of 2 is -2, and the opposite of -4 is 4. We're going to use the opposite operation. So the opposite of adding would be subtracting, and the opposite of subtracting would be adding. So I can use inverse operations to solve one-step equations. So in order to solve an equation, you need to get the variable alone on one side of the equal sign. So we want to get our variable all by itself on one side of the equal side. Does not matter which side you get it on, okay? I would just use it, keep it on the same side that it is already on. So if the variable is on the left side, keep your variable on the left side. If your variable is on the right-hand side, keep your variable on the right-hand side. But you just want to get it alone, okay? Remember that a variable is a missing number. Variable is a missing number. This is going to be what we're solving for. So now we're getting into algebra where we're actually having to solve for x. So when solving an equation, you must first determine the inverse operation. And remember, inverse means opposite. Then we want to apply the inverse operation to both sides of the equal sign. Both sides of the equal sign. Just like with fractions, when we said, what you do to the bottom, you have to do the top. Now it's what you do on the left-hand side of the equal sign, you also have to do on the right-hand side of the equal sign. We want to make sure it stays balanced because the whole idea about an equation is that whatever's on the left-hand side equals is the same as what's on the right-hand side. So if I do a specific operation on one side, then I have to do that same operation on the other to maintain that equalness, to maintain that balance. And then lastly, you should always substitute your solution back into your equation. So substitute your solution just means answer, back into the equation to check your work. All right, so that's the notes part. So let's go ahead and move on with the examples. At this point, if you need to pause the video so that you can go over the notes, then you may do so. Otherwise, just keep it playing. So right here, we have x plus 2 equals 5, okay? First, you just have to know how to read these things, okay? You actually say x plus 2 equals 5. Just read it left to right. Now, our first step, if we go back up, if you remember, our first step said that we want to find the inverse operation, find the opposite operation. So take a minute and think about what is the opposite of plus 2. Well, that's going to be -2. So we're trying to get our variable all by itself. So I'm going to circle my variable to kind of put it in a bubble, meaning that I can't even look at my variable. I can't even touch it until I get rid of this plus 2. And in order to do that, the opposite of plus 2 is -2. So 2 minus 2 is 0, so I can just cancel that out. And then I'm left with x on the left-hand side. It's all by itself. But remember, what I do on the left-hand side of the equal sign, I have to do on the right-hand side of the equal sign. So I also need to subtract 2 from 5. So 5 minus 2 is 3. And that's your answer. It's that simple. Let's make sure we did this correctly. So I'm going to actually take my answer. So now we are saying that x is 3. So I'm going to plug 3 in for x, and I'm going to just check my work super fast. So I know that 3 plus 2 is actually 5. So when I ask myself, does 5 equal 5? I get to say yes, it does. So that's just a quick, easy way to check yourself. And the whole idea of doing the inverse operation is you guys should have known right off the bat that that answer was going to be 3. You know that. You know what you know what you know. Well, how did you figure it out? Well, in your head, you probably said, well, 5 minus 2 is 3. That's exactly what I've done here. 5 minus 2 is 3. All we're doing is showing the backwards work that we're doing. So we're actually working backwards to figure out what is my x, and that's all we're doing is showing that work. So you already knew in your head, oh, this is what the answer should be. Now we're just putting it down on paper and showing it, okay? We're going to stick on the left-hand side to do all of the adding first, and then we'll move over to the right-hand side to work with subtracting. So again, I want to get my x all by itself, so I'm going to circle my x because that's what I'm trying to get by itself, okay? And take a minute and ask yourself, in order to get rid of the plus 12, because right now plus 12 is in my way. It's like an obstacle in a video game. You have to get through this, brick wall before you can access the treasure, okay? It's the same concept that in order to get to x, in order to do anything with x, we have to get rid of this plus 12, this obstacle in our way. So take a minute and think to yourself, what is the opposite of plus 12? Well, it's going to be minus 12. So I subtract 12. Again, 12 minus 12 is 0, and I don't have to write 0. If you want to write 0, you can. There's really no point in it, though. Just know that you can cancel those out, and all you're left with is x on the left-hand side equals, and remember, what I do on the left-hand side, I have to do on the right-hand side. So I'm going to do 42 minus 12, which is going to give me an answer of 30. So x equals 30. Let's check our work super fast. So 30 plus 12 equals 42. Now I know that 30 plus 12 is indeed 42. So when I ask myself, does 42 equal 42? I get to say yes. Now you need to actually do the work here. Please actually do 30 plus 12 like I've done right here, because say I accidentally thought that that was a 31. Say I said my final answer was a 31, and I said 31 plus 12 is 42. Well, it's not 42. So I can't just assume that my answer is going to give me my original final answer of 42, because I may have done something wrong. I may have subtracted incorrectly. So when I do this work, when I check my work and I say 31 plus 12, and I realize that that's 43 and not 42, then I realize immediately, oh no, I made a mistake. I need to go back and fix it. Okay, that's called checking your work. You don't want to just assume that everything is right. Okay, nobody's perfect. We all make mistakes. It's very easy to just make a simple adding and subtracting error. So please actually do that work. Okay, oops, sorry. So now I'm going to go down. I'm actually going to skip this next one. That's going to be for homework. But I want to go down here to 16 plus x equals 68. So here's the thing. No matter where your x is, whether it's on the left-hand side, the far left, or it's in the middle, you're still looking for how to get rid of the number there. But in this case, you're not looking at the addition sign that's right there. You're going to be looking at the kind of number that it is. So that's a positive 16, right? We always know that there's an invisible plus sign in front of a whole number if it's there. So I'm not looking at my actual plus sign, but now I'm looking at the type of number that is 16, which is a positive. And I know that the opposite of positive 16 is going to be a negative 16. And that's how I know to subtract and not add. Okay. I would definitely rewind right there if that was a little confusing. Rewind and listen to it again just to make sure. Okay. But again, we want to do that on both sides. So I'm going to subtract 16 on both sides. 16 minus 16 is 0, so I'm left with x equals 68 minus 16 is 52. And here's the other thing. If say I accidentally said that that was a plus 16. Well, does 16 plus 16 give me a 0? No, it doesn't. It gives me 32, which is not what I'm looking for. I want that to be able to fully cancel out. Okay, so we want to be sure that's another way to just check your work and make sure that you're actually going down to 0. Okay, that's going to be it for the adding. I'll put up another video for the subtracting that you guys can watch then. Okay, bye.